Hello, everybody. So, in today's lesson, we're going to finish up Module 8, and our topic today is solving percent problems. So, let's look at the Explore activity. We're on page 217 of the 6th grade Go Math textbook. So, modeling a percent problem. So, we can use a model to solve percent problems. So, for instance, a sports store received a shipment of 400 baseball gloves. 30% were left handed. How many left handed gloves were in the shipment? Okay, well, we have to answer how many left-handed gloves were in the shipment. So what information do we need to solve this problem? Well, we need 400, that there were 400 baseball gloves total, and that 30% were left-handed. So what does 30% mean? 30% means 30 out of 100, or 30 per 100. So basically we can conclude that for every 100 baseball gloves, there's 30 left-handed gloves. Okay, so we can complete this diagram here. So we see 30 out of every 100. So we have, again, 30 out of 100. Add another rectangle. We have 30 out of 100 and 30 out of 100. So why do we have four rectangles? Because there's 400 baseball gloves. Why are there 30 in every set of 100? Because it says 30% were left-handed. So 30 out of every 100 is left-handed. So, so compare the diagram to model this. Complete the diagram to model the situation. So this is what we did to complete it. Okay. Now describe how the diagram models the shipment of gloves. Well, the large rectangles represent 100 gloves. So four rectangles represent 400 gloves. The small rectangles represents 30%, or 30 out of 100. So again, in words, this is what our diagram is showing. The large rectangles represent 100 gloves. So there's four rectangles representing 400 gloves. Each of the small rectangles represents 30%, or 30 gloves that are left-handed. So how can you use the diagram to find the total number of left-handed gloves in the shipment? Well, how many sets of 30 do we have? We have 1, 2, 3, 4 sets of 30, or 120 gloves. Or we could say 30 plus 30 plus 30 plus 30. And we'd still get 120 left-handed gloves. All right, use a bar model to solve this problem. The bar represents 100%, or the entire shipment of 400 gloves. So we see here 400 gloves equals 100% of the shipment. So the entire shipment was 400 gloves. All right, and so we see 0%, there would be 0 gloves. 10% represents 40 gloves. 20% is 80 gloves. So how much is it increasing by each time? 40%, right? By 40 gloves. So every 10% equals 40 gloves. So our next one would be 120, then 160. Again, all I'm doing is adding 40. 200, 240, 280, 320, 360. Okay. So let's go to page 218. So how did we determine the labels along the bottom of the bar model in step D? Each bar was worth 10% of the total, and each bar was worth 40 gloves. So every 10% was worth 40 gloves. So we're going to have 10 sets of 40, right? Because there's 10% and 100%. So 10 times 40 is 400 gloves. So 2, how can we use the bar model to find the number of left-handed gloves? Okay, well, if we just look at the bar model, all we have to do is find 30%, right? 30% was equal to 120. Well, the shipment was 30% of the gloves were left-handed, so 30% equals to 120. All right, how about a concept known as finding a percent of a number? So a percent is equivalent to the ratio of a part to a whole. Ratio of a part to a whole. To find a percent of a number, we can write a ratio to represent the percent and find an equivalent ratio that compares the part to a whole. So, for instance, to find 30% of 400, we can use proportional reasoning. So 30%, the part of 100% is 30. So 30 over 100, part to whole. And the whole shipment was 400 gloves. So we have to find the part of the shipment that's equal to 30%. Well, we can just use, how do we go from 100 to 400? You just multiply by 4, right? So do the same thing to the numerator on this. 30 times 4 would give us 120. So 120 out of 400 is 30% of 400. We could also use multiplication. And in this type of situation, the word of indicates multiplication. So what is 30% of 400? Well, 30% means 30 over 100. Of, it means multiply, of 400. So 30% of 100. Well, we know what we can simplify by dividing by the greatest common factor, 100. Leave us 1 there and 4 there. So we'd have 120 over 1, or 120. So either of these two methods will work. All right, example 1. Use proportional reasoning to find 28% of 25. So write a proportion first, comparing the percent to the ratio of part to whole. All right, so we have 25 as the whole, right? Of 25. We don't know the part. We know it's 28%, so we know the part of the 100% is 28, so 28 out of 100. So how do you go from 25 to 100? You multiply by 4. 25 times 4 is 100. So what number times 4 is 28? Well, 4 times 7. Okay, so 28% of 25 is 7. Okay, let's look at page 219. Part B. We can also multiply a fraction to find 30% of 60. So remember we said that of means multiply. So 35% of 60 means 35 out of 100. So 35 hundredths of 60. 35 hundredths of 60 is the same as saying 35 hundredths times 60. And so you could simplify. In this example, they didn't. They went ahead and just multiplied 60 times 35 and got 2,100 over 100, and then just simplify. So 2,100 divided by 100 would be 21. Another method we could use is just to multiply by a decimal to find percent. Like in this one, we could have said 0.35 times 60. And got 21. So in this example, we're going to say find 5% of 80. Well, 5% is 5/100ths. How do we write 5/100ths as a decimal? As 0.05. So just multiply that. 180 times 0.05, and we'd get 9. Two decimal places, 9. All right, let's look at number 3. In B, the percent is 35%. What is the part and what is the whole? Okay, so our part we're finding is 21. 21 is the part. And 60 is the whole. Explain how to use proportional reason to find 30% of 600. Okay, so 35% is 35/100ths. And that's going to equal what part of 600? Okay, so the part of 100 is 35, so 35%, and we need to find the part that is 35% of 600. So here we're going to multiply 35 by 6, since 100 times 6 equals 600. Okay, so how do they go from 100 to 600? They multiplied by 6. So do the same thing to the numerator. 35 times 6 is 210. So again, how did we set that up? 35%, that's easy, 35 per 100. And it's going to be equivalent to some part out of 600. We multiply 100 by 6 to get 600. Multiply 35 by 6, and we get 210. Okay, all right, let's try some. Number 5. So find 38% of 50. So I'll get some scratch paper. Make sure you have room to do these. So 38% of 50. Well, we know 38% means 38 out of 100. Of 50, so 50 is the whole. And we have to find the part. All right. So 100, how do we go from 100 to 50? We're actually divided by 2, right? So 38 divide by 2. What's half of 38? Well, if I had 20, that would be 40, right? Half of 40 would be 20. So half of 38 is 19. Number 6, 27% of 300. So we're going to start with the percent part. The part is 27. The whole is 100 of the number. So of 300 is the whole. And we have to find the part again. All right, how do you go from 100 to 300? Multiply by 3. So also multiply 27 by 3. So we get 81. Number 7, 60% of 75. So 60%, 60 out of 100 equals what percent of 75? Well, in this case, it's not easy to go from 100 to 75 or from 75 to 100. But what happens if we reduce this fraction? Well, I can see that we can already eliminate the end zeros by dividing by 10, right? Well, I also see that 2 is a common factor of 6 and 10. So if I reduce 6/10 by dividing by 2, I'd get 3/5. Oh, well, I know any number that has 5 as a factor will go into a number that ends in 5. So now I can easily convert this. So how many 5s does it take to get to 75? It takes 15. Okay. If we're not sure, we go 75 divided by 5. Okay. So 3 times 15, 45. Okay, so now let's say you got to this situation, you're like, oh, I don't know what to do. I don't know how to convert that or what factor to multiply this by. So what we could do in this case instead is just go 0.60 because 60% of 100 is 60 out of 100, right? 60% equals 60 out of 100. How do we write 60 hundredths? 0.60 of means multiply. So 0.60 times 75. 2 decimal places, 45. Okay, so you can always multiply by decimal instead. All right, let's go on to page 220. How do we find the percent when you're given a part and a whole? Okay, so in this case, the percent's missing. So again, though, we can use proportional reasoning to solve problems in which we need to find a percent. So here, the school's principal spent $2,000 to buy some new computer equipment. Of this money, $120 was used to buy some new keyboards. What percent of the money was spent on keyboards? What percent of the money was spent on keyboards? Well, he spent $120 total on keyboards out of his $2,000. So since we want to know the part of the money spent on keyboards, compare the part to the whole. The part in this case is $120. The whole is $2,000. So we can write a proportion comparing the percents to the ratio of part to the whole. So what part of 100, what percent is equivalent to 120 out of 2,000? So how do you go from 100 to 2,000? Well, that'd be multiplying by 20. So what number times 20 is 120? Well, that would be 6, right? Okay. So the principal spent 6% of the money on keyboards. Right, so number 8. Write 57% as a ratio. Which part of the ratio represents the part and which part represents the whole? And explain. Okay, so 57% equals 57 out of 100. 57 is the part and 100 is the whole. So in explaining this, 57%, what does that mean? No, that means 57 out of 100, where 57 is the part and 100 is the whole. How do we know it's 57 out of 100? Well, because the percent sign means out of 100. So 57% would mean 57 out of 100. All right, let's look at number 9. So out of 25 students in Mrs. Green's class, 19 have a pet. What percent of the students in Mrs. Green's class have a pet? Okay, so what percent of the students in Mrs. Green's class have a pet? Out of 25 students, so that's the total, the part is 19. So let's go ahead and solve this. So we have 19 out of 25 equals what percent out of 100? Okay, well, how do you go from 25 to 100? You multiply by 4, right? There's 4 25s in 100, so 19 times 4. So we'd get 76%. 76% of the students in Mrs. Green's class have a pet. All right, let's go to page 221. So how do we find a whole given a part and a percent? Okay, well, again, we can still use proportional reasoning to solve the problems in which you know a part and a percent and need to find the whole. So example 3, 12 students in the school choir like to sing solos. These 12 students make up 24% of the choir. How many students are in the choir? How many students are in the choir? Well, we know 12 students like to sing solos. That's 24% of the whole choir. So since we want to know the total number of students in the choir, compare the part to the whole. What is the part? The part is 12. That's not the total number of students in the choir, right? Only 12 out of all of the students in the choir like to sing solos. So the whole is missing. We don't know that. So let's set up the proportion, comparing the percent to the ratio of part to whole. So 12 over something equals 24%. Well, we know the whole because percent means 100. So 24 over 100. So how do we go from 12 to 24? We multiply by 2. So what number times 2 is 100? 50. So there's 50 choir members or 50 students in choir. All right, so number 10. In example 3, 24% is close to 25%. How could you use this fact to check that 50 is a reasonable number for the total number of students in the choir? All right, so 24% is close to 25%. So let's do this. Since 24% is close to 25%, find 25% of 50. 25% of 50. So we could multiply that. And we'd get 12 and a half. Well, 12.5 is close to 12, isn't it? Sure. All right. So here what we're doing, saying 24 is close to 25%. So what we're trying to say is 25% of 50 close to the 12 students that like to sing solos? Well, 25% of 50 is 12 and a half. Well, that's very close to the 12 students. So 50 is a reasonable number for the total number of students in the choir. All right, number 11. 6 is 30% of what? 6 is 30% of what? All right, so here we have 30% out of 100. And we have the part. 6 is. We don't know the whole. So we have part over whole. And they didn't give us that. So how do we go from 6 to 30? We multiply by 5. So what times 5 is 100? 20. 20 times 5 is 100. So 30% of 20 is 6. 15% of what is 75? 15% of what is 75? So they didn't give us the whole. 15% of what? What whole number is 75? Right? How do you go from 15 to 75? We multiply by 5. Okay. 5 times 5 is 25. Regroup. 5 times 1 is 5, plus 2 more is 7. So 75. So 100 times 5 would give us 500. So 15% of 500 is 75. Can we check that? Sure. So we can take 500 and multiply by 0.15, because 15% is 15 over 100. How do we write 15 over 100 as a decimal? 0.15. And we get 75. Okay, so that is a correct answer. All right, let's look at page 22, 222. Okay, and we're going to work through these next 6 problems, and then we'll stop at the end of this one, at the end of the guided practice for part 1, and then we'll come back and do the independent practice together. All right, number 1 on page 222. A store has 300 televisions on order, and 80% are high definition. How many televisions are on order? How many televisions on order are high definition? Use the bar model and complete the bottom of the bar. All right, so how many televisions on order are high definition? Well, we know they have a total of 300, and that's 80% are high definition. So 100% of this televisions on order is 300. They order 300 televisions. So when all 300 come in, that's 100%. And they're telling us that right now, 10% of the shipment will be 30. We need to find out how much is 80%. So all I have to do is count by 30s, right? Because 10 times 30 is 300. So 2 30s would be 60, 3 30s, 90, 4 30s, 120, and so on, right? So just keep adding by 30s until we've completed the bar model. All right. So how many bar models on order are high definition? We'll find 80. So 80% is 240. All right. Use proportional reasoning to find 65% of 100. So we know the part is 65. It says 65%. So 65 over 100 of 200. So they give us a total amount of 200. We've got to find the part. Okay, so how did they go from 100 to 200? Multiplying by 2. So multiply 65 by 2. And if you double 65, you get 130. All right, number 3, use multiplication to find 5% of 180. 5 100ths, because 5% means 5 100ths of 180. 5 100ths times 180. Could also use a dot, right? So multiply 5 times 180. We'd get 900 100ths. 900 over 100 is 9. So 5% of 180 is 9. Okay, number 4. Alana spent $21 of her $300 paycheck on a gift. What percent of her paycheck was spent on the gift? So we have to find the percent. So we know it's going to be some percent over 100. Okay, the percent is missing. What's the part? Well, she spent 21 out of her $300. So how do you go from 100 to 300? Multiply by 3. What times 3 is 21? 7. So she spent $7 of her paycheck on the gift. Oh, not $7. We had to find the percent, didn't we? 7% of her check on the gift. All right, a pizza pie. 9% of the pizzas made last week had broccoli on them. If 27 pizzas had broccoli, how many pizzas in all were made? How many pizzas in all? Okay, so that's telling me I have to find the whole number of pizzas made. 27 tells me the part. 9% tells me 9 out of 100. Okay, well, how do you go from 9 to 27? Multiply by 3. So 100 times 3. They made 300 pizzas last week. And number 6, how can you use proportional reasoning to solve problems involving percent? All right, well, the first thing we have to do is read the problem, right? We have to read the problem to find out what we're finding. We have to find out, are we finding the part of a whole? Are we finding the missing whole number? Or are we finding the percent? Okay, so once we've done that, then we're going to use the proportion. Part over whole equals the percent part over percent whole. Okay, so after we've read the problem and we've determined what we need to find, we're always going to use this setup for the proportion. Part to whole. Okay, so the total amount of some number of objects. The part would be like 16 is 40. 16 is what percent of 40? 40 would be the whole. 16 is the part. Here in that case, we'd have to find the percent. But we know that the denominator has to be 100 because percent means per 100. All right. All right. So let's go ahead and stop there for part one. And so next time I see you, we'll work on the independent practice problem. And so until then, I'll see you soon.